Today we are going to be looking at simple circuit analysis. We have done so many videos in the past on direct current electricity. So today we are just moving it forward on simple circuit analysis by looking at series circuits and also parallel circuit, how to analyze them. In the previous classes we have discussed what DC circuit is about, what the symbols represents, resistors and the cell, and how we can calculate the total resistance in the circuits and what have you. Remember, don't forget to click on the subscribe button under this video and to drop any comments after all. Okay, so if you have a circuit where you have a series connection of two resistors, definitely the same current will be moving through the circuit. You can see that the same current, I total, is moving through the two resistors, and the current is actually coming from the voltage source. But if you have two resistors that are arranged parallel to the voltage source, the current will be different, but the voltages in the two of them will be the same. That is, the total voltage dropped here will be the same thing as the total voltage dropped here, but the currents will be divided. So there is high need for us to know what the voltage division will be, the voltage across resistor R1, and what the voltage across resistor R2 would be by using what we call voltage divider and current divider. Can we get the total resistance here? We have something called voltage divider rule. Voltage divider rule will tell us the total voltage that is dropped across V1 and the total voltage that is dropped across V2. Remember, your V1 plus V2 is the V total. So how do we find the V1 and the V2? We can first calculate the total resistance. Remember, total resistance R total here, since they are in series, is what? R1 plus R2. So that means my I total will be what? What will be the total current? The total current will be V total over R total, which is V total over R1 plus R2. Now with that, we can just move on to find the voltage across the resistor R1. Since we know the I total, and the I total will be the same thing here and the same thing here. Remember, we have the same current. The I total is the same thing as I1 and the same thing as I2. Look at I total is the same thing as I1 equal to I2. So the total current that is passing through these circuitous elements, R1 and R2, is the same thing as the total current coming in from the voltage source. But the voltage drop here plus the voltage drop here will give you the total voltage supply. So can we calculate the voltage drop in R1, VR1? VR1 is what? I total R1. So what's I total R1? We have R total, I total, this is I total. Don't forget, I total, so I have V total over R1 plus R2 into what? R1. That is for R1, the voltage across R1. The voltage across R2 is what? I total R2. And that is what? V total R2 over R1 plus R2. This is the voltage across R2. So we call these two, we call them the voltage divider rule. Voltage divider. Now the reason why we call them voltage divider is that these two formula will tell us what the voltage across this resistor will be, that's voltage R1, and what the voltage across this resistor will be. Even if we have multiple resistors, there's a way we combine them. We'll combine two as one. We'll find the voltage across two of them. We'll find the voltage across one of them. Then we'll now break it down further. So here is the voltage divider rule. Likewise, if you have resistors connected in parallel, the current flowing in the two resistors will be different, unlike when they are connected in series. So here we have different currents flowing in the two resistors, R1 and R2. But here we have the same voltage drop here is the same voltage here, but its volt total is V1 and it's also V2. This is V total. Unlike what we have here, here we have the same current flowing in through. Here we have different currents but the same voltage. So therefore we are going to have what? A current divider. We have a current divider here. Current divider rule. Don't forget, the reason why we have a voltage divider rule here is because we have different voltage supply across the two resistors, R1 and R2, and that gives us the two voltages, VR1 and VR2. But here we have different currents across the two resistors, R1 and R2, so we're going to have what? A current divider across R1 and R2. Can I get the total resistance? R total. R total for the two resistances is R1, R2 over R1 plus R2. This is the R total across the two resistors. So can I get the voltage across the two resistors? The voltage across the two resistors, since they are the same, V total. Don't forget V total is what? I total, R total. And what's that V total? That means the V total is what? The I total. Remember, I total is current. From here, I can get the I total as what? V total over R total. This is the I total. Okay, so this I total divides into 2. Pause. The V total is the same thing as the V1 and the same thing as the V2. Don't forget, I said that from here. The V total, the total voltage, is the same thing as the voltage drop across the V1 and the voltage drop across the V2. So can I find the I1? I1, don't forget, I1 is V1 over R1. So what is I1? I1, V1. What's my V1? I have what? I total, R total, R1, R2 over R1 plus R2 into what? R1. This is the R1. Okay, this is R1. And the whole of what I have here is V1. So that means R1 cancels this. And we have what? We have I total, R2 over R1 plus R2. That is the current I1. The current I2 likewise, will be what? V2 over R2. Don't forget, from Ohm's law, my I is always V over R. So my current, I have it as what? What's V total? V total, still the same thing here. V total, don't forget our V total was I total, R1, R2 over R1 plus R2. That is where we got this expression from here. Okay, so we're transferring it here. That's what I total, R1, R2 over R1 plus R2 into what? Divided by R2. So the R2 also cancels. So what do we have? We have I2 as what? I total, R1 over R1 plus R2. So in summary, pause. As a summary, my I1 is I total, R2 over R1 plus R2. And my I2 is I total, R1 over R1 plus R2. This is the current divider. So we have voltage divider for when the two resistors are in series, and we have current divider for when the two resistors are in parallel. We'll quickly take illustration to show this.